Algebra 2 mini lecture lesson 112, sum and difference identities. We have a formula sheet that has these on it. So these can help you find, like how you can find things using your unit circle, right? You can find these like, 30 or 60 or there's certain degree measures or radian measures that you can find on your unit circle using special triangles. But if you're given a degree measure or an angle measure that's not one of your special unit circle measures, you can use these sum and difference identities. For example, if you had 105 degrees, then you could find two angle measures that add to 135, like 60 and 45, and you can still use your unit circle or your special triangles to calculate sine and cosine of that, or tangent. So we'll practice. I'll show you some examples, and the book, there's plenty of examples in the book using that. And then let's show you your rotation matrix. So this is very cool. This matrix right here will rotate points around it'll rotate things clockwise or counterclockwise around the origin. So, and you guys just learned, you already know how to do matrix multiplication. So you can, if you wanted to rotate something like 45 degrees counterclockwise around the origin, you can plug in 45 for all these thetas right here, and then you can do some matrix multiplication and get the ordered pair. This rotation matrix. Very cool. And so I'm just going to show you how to do some of these. So we're going to find the exact value of tangent 105. So when you look on your unit circle doesn't have tangent. We know tangent is sine over cosine. Usually if I'm asked to find tangent, I usually just use the special triangles like my 30, 60, 90 or my 45, 45, 90 triangles, but no matter how hard I look, I'm not going to find 105 degrees on here. So earlier I mentioned that 105 degrees, you could use 135 minus 30, or you could use 60 plus 45. I'll probably just use 60 plus 45, that's less complicated. So what I'm going to do, and let's do the problem, as I wrote down the formula, I just took it. See, we got our formula sheet. It's on your formula sheet right there. So I'm going to, since 60 plus 45 equals 105, I just kind of plugged them in for A and B. So I said A is 60 and B is 45. And see how I plugged them in the spots where they go. Now I'm going to evaluate this, but I don't, like I said, I don't want to really use my unit circle because it's easier just using a triangle for me to do this. So there's my 1, and there's my, I'm just going to make the little empty spots where all my values go. Okay, so what's tangent of 60? So tangent, I already wrote 45. Let's get tangent of 60. We'll put it over here. So I don't know if you guys remember, you had your unit circle. All students take calculus. Everything is positive in this quadrant. That says all. Sine is positive in this quadrant, which means all the other ones are negative, like tangent and cosine. Tangent's positive here, cosine's positive here. I want tangent of 60. I'm making a recording. Okay, just drop it off. Thank you. Okay. I've got tangent of 60. I'm trying to find tangent of 60. So I'm going to open up an angle of 60 degrees. And then, so that's 60. So this is my 30, 60, 90 triangle. And so I know some things about this triangle. I know that the side across from 30 is 1. And the side across from 60 is root 3. And that's 2. so now I can find the tangent of 60 easily because I know tangent is the TOA of SOHCAHTOA. So opposite over adjacent, so there's the angle 60, and opposite is √3, and adjacent is 1. So I got √3 over 1, so this is √3 right here. That's tangent of 60. And there's another tangent of 60 right here, so that's √3. What's tangent of 45? Well, I drew a triangle. That's 45. The triangle's not drawn to scale. That's 45. If that's 45 and that's 90, that's got to be 45. So that's 1, 1, √2. It's my special triangle that I memorized. So tangent of 45, tangent is opposite over adjacent. So it's going to be 1 over 1. It's going to be 1, isn't it? Tangent 45 is 1. We already knew that. So now we've got √3 plus 1 over 1 minus, well, √3 times 1 is √3. We got the radical in the denominator, so we're going to go ahead and rationalize. My pen won't do what I want. I'm trying to tell it to make a 3. Okay, so multiply by the conjugate to rationalize the denominator. So if I FOIL these out, 1 times 1 is 1, and 1 times √3 is √3, but then when I go this way, I'm going to get a negative √3, and it's going to cancel out. And then the negative √3 times negative √3 times √3 is going to be negative √9, which is negative 3. So you can take your time and FOIL that out if you want to. Same thing up here, but this will be √3 times 1 is √3. √3 times √3 is actually √9, which is 3. 1 times 1 is 1, and 1 times √3 is √3. So if I get that all cleaned up, there's 3 plus 1, that's 4. √3 plus √3 is 2 √3. 1 minus 3 is negative 2. I can cancel my 2's out, and I'll have, and I'm going to bring this negative out front, so I'll have negative 2, and then I have to distribute it, minus √3 is what I'm getting. Let me check that, make sure that's right. Yeah, they wrote theirs as negative √3 minus 2. They're the same thing. Okay, so I got 2 minutes left on the video, and I actually want to do the whole problem letter B, so I'll start a new video for the rest of the letter problems.